Hello, good afternoon all. So, as per the last lecture's plan, I have decided to tell you about some real life approach examples of FEA. So, without wasting much of time, we'll move towards our presentation. So, I will share my screen and I am opening my PPT. So, this is FEA real life approaches in various fields. I started now. Now, first thing, in the last lecture, we have seen about the FEA, that is discretization of given quantum into small number of finite elements. So let's see some interesting examples. So I hope most of the people from your division have seen the movie Avengers. Starting from, I think, last two parts, Thanos was there. So in this image, you can observe the person is having some neck on his face, and on the left side here there is a canvas. So as this person moves, as this person moves means movement of this person controls the movement of canvas. So you can see on his face some right angled triangles are made here. So I will denote it with the help of here. One right angled triangle is there, another right angle triangle is there. That is, squares are divided into two parts and that will become right angle triangle. So that is nothing but in our simple language called animation. But that animation is done in HF software. So that is not for mechanical purpose, but I am just telling the machine can be used to simplify our things because normal face can be a Thanos shaped face. Thanos shaped face we can make it in software and we have to relate it to our any of the human face and depending on human face behavior that Thanos face will be controlled. Means that human face controls the Thanos face. So that is the motto behind the theory, behind that theory. That is every face is having mission. Now the second example I am going to tell you. This I will clear all drawings. Now the second example. So this is a face. See, some of you might be drawing the sketches by using some grease. So if you want, you can go for any videos, YouTube videos like that. So there are some faces which we have to make the tree and we have to follow. Suppose I will tell with the help of the annotation. That is, suppose if this grid is there, this particular grid. This particular grid contains the left side of eye and some white portion, some black portion, and some brownish portion is there. If I consider the color image, so that image is there. Then hair side. So this hair side contains some of the white portion due to light effect, and some of the portion is black, which is shaded and mixed with light. So some portion becomes gray. So according to the color combination, we have to choose the proper shade while drawing any kind of sketch. But before that, we have to divide this whole sketch into number of small elements. This element is square and we are dividing the given space into number of small elements and that division is nothing but in our term we can call it as a FE. Okay, but that is done with the help of drawing, but we have to take positive things from that. That is, we can divide the any structure because this space, if I have drawn randomly, then I cannot go for exact face drawing as a beginner. If I am experienced, I can draw directly the face. But if I am the beginner and I am not well trained, then the face shape, likewise here coming from ears, this portion might have become wrong for the beginner. So for that purpose, we have to only and only use the grid that is in our language we can call it as a mesh. Now this meshing for this part about this part I was talking about the Thanos part. That meshing was there in 3D because space is the 3D concept, so we can move it. But part, this sketching part is 2D part, so we have to go for 2D machine. So that type of element we are going to cover in next webinar. But in this webinar, we are going to cover just basic things which are totally related to our FEA. Now, I hope you have got all the things related to machine. Means we have to divide the given object into number of small elements, and we have to go for analysis because we can't analyze the analyze the shape of the face, but we can analyze the sphere anytime. Okay, so I will clear this first. Then I will move towards next slide, next application. Now in medical field, the person is walking. The person is walking having some bones, and that bone structure can be analyzed very easily. Here, one bone structure can be modeled in any of the software. Just as I have told you previously, Creo software we can use, CATIA software we can use, SolidWorks also we can use, Unigraphics, Ideas, lot of softwares are there for modeling. But we have to go for particular software and we have to convert that file into .stp, that is text file, or .igs, that is I will write here .stp or .igs. So .stp or .igs format we have to use, and we have to convert our Creo file to the export our Creo file or CATIA file into .stp format or .igs format. No matter what it is assembly, it is an assembly or it is a part, but we have to convert whole assembly or whole part into .stp and .igs format, and then we can import it to our software, that is finite element analysis software, and then we can go for analyzing the field. See here, this is the model which is already made in any kind of software, and that model we have analyzed by using ANSYS or Hypermesh. Particularly for this, it is showing for ANSYS. So for that purpose, we require particular constraints, that is fixed constraints, because uh, we are having some fixed constraints everywhere. No body in the universe is freely suspended. We can the body which we need to analyze is not freely suspended. That is the case where only vacuum is there. So for vacuum, we can take the condition that body is freely suspended. So we have to do the conditions like this. There is another analysis and provision for that. But we are restricted only for the things which are having some constraints. That constraints we need to apply. So suppose this bone is having some fixed constraints or moving constraints, and here we have to apply some constraint, that is fixed support or moving support, anything. And here the body weight is acting at this point. So at this point, body weight is acting, and this bone is having some modulus of elasticity, some Poisson's ratio, that is mu, and some density. So that much parameters, at least that much parameters, you have to enter for this. Then we have to give for any fixed support constraint. We have to apply the force here. Then we can see where the failure will be occurring. So here the redmost part is there. The redmost part is counted for failure. Why it is so? So I will tell you with the help of this diagram. So this diagram shows some one mass stresses. So here the blue one is minimum and red one is maximum. So maximum stress is nothing but that is a failure we are considering. But that maximum we have to choose by considering our standard design procedure, that is SDP, standard design procedure, and from that we have to calculate the allowable stress. If our stress exceeds that, then our model is got failed and we have to restructure or we have to change, because bone is having some E, some mu, and E, some mu and rho, but we are giving input as a biomaterial to the human body. We are changing that biomaterials and we are applying that biomaterials into the, we are inserting that biomaterials into human body. But that biomaterials is having different modulus of elasticity, different Poisson's ratio, and different density than that of original material of bone which is existing in our body. So we have to change the material and we have to give input and we have to see the but before inserting, as I have told before inserting it in a human body, we should first analyze it. Otherwise, if we are directly implementing such a things into the human body, and if it is failed after inserting some biomaterial to human body, then it will be harmful to that human being. And believe me, it takes a lot of time and it may cause harm to that human body. Okay, so for that purpose, we need to first check up with FEA, then we have to go for manufacturing, and then we can go for implementing the things. Now I will just clear these things. Now next one, the data analysis is also shown. I will talk later because later some images are there which I am going to show. But data analysis also is also same thing. We need to define the force. We need to define some fixed support. So we can define it, and we are going to see in detail for this subject. So I'll clear these things first, and then I will move towards next part. That is brain, human brain. See here, some elements are there. Some elements are there. Some yellow colored elements and some blue colored elements. But all are triangular. You can observe here. All elements are triangular in nature. Every element is, I will show here, all elements are triangular like this. This is the structure of element which are interconnected to each other, and all elements are triangular, you can see. So these elements are connected to each other, but they are looking triangular. But our brain is not the 2D image, 2D thing. Brain is 3D thing. So for third dimension, we have to consider the Z direction also. See, suppose this is our X direction and this is our Y direction, then Z direction should be there. So for that purpose, we should call it, the element used is tetra element. Element used for this kind of brain is tetra element, because we can't use simple triangular element which will go for only surface thing. But if we have to go for solid, then we have to go for tetra. So I will tell you later in the next lecture how to choose the element. But for example, I have shown this, the use of the FEA in the medical field. So I will clear this. Let's move towards next part. This is the next model where we can, this is the analyzed brain, where we can see different kind of controls which we can observe. Now moving towards next slide. See, one bridge is there and it is simply supported. So for that purpose, we have to consider this part, and particularly this part for the loading constraint. As of now, I will tell this is the simply supported view. As per this, we can convert this into this. So converting the given structure into number of elements. See here, The element considered is only in one direction, x direction. Previously, you might have observed the element for face, drawing the face. I have told you 2D drawing, but in second slide, I have told the element for the brain is 3D. But this is not. Can Are you observing here y direction anywhere for this beam? Only consider this beam, not suppose. No, this is only 1D. So we have converted the given object, that is this bridge, into the 1D element, and we have converted these two supports to simply supported. So this we can call it as a simply supported beam. And if the person is moving on that bridge, then we can consider it as a point load which can be applied at the center or anywhere. That's how we can convert our given object into the finite element. This is nothing but, yes, it is a finite element model. So we can divide this 1D beam into number of small parts also. Small part also. So that will be element number 1, element number 2, that will be element number 3, element number 4, 5, 6, and so on. But the element endpoints are called as nodes, as I have discussed in last lecture. So this is the conversion of this bridge into simply supported beam. Sorry, here is fine. Now next one. This is the beam structure after analysis. So here there are some, you can observe here, observe here. Here there is one red patches at joints. So according to our structural method, where we are joining the teeth, that is veins, that are having some kind of failure, that may have kind of failure because they are weak than that of complete material. If rod is there, then rod cannot fail in between. But rod is connected to the another rod, then the joint may fail. So such a failures are shown in this figure, so you can observe this. So if the failures are there, then we can change the material, or we can change the type of joint, or we can change anything. And after that we can, but this should be before manufacturing. This structure should be before manufacturing. Once it is manufactured, then manufacturing cost will waste and time will waste. So to save our time and manufacturing cost, one person must go for FEA method. So next slide. In this, another structure is shown. The structure is having first structure. So this is the red patch. You can observe here. This is the red patch. These are some small points called as neos. And these are some elements you can consider. But this is very complicated structure. You can observe this. This is very complicated structure. So for that purpose, we need number of hours to see, and we can model it and we can analyze it after application of VS. So for that reason, it takes some time and experience also. So just now, remember the thing to remember is we can analyze the things which we have to manufacture. Now, next slide. So this is one cycle structure which might be the final year project of some students, which follows the cleaning process, bicycle pedal cleaning process. If one person is sitting on the bicycle, then that wheels are moving and cleaning process is there. Suppose these are having some brushes and this process is having some cleaners. Some water arrangement also we can make, but this is the mechanical arrangement we can make. But this model should be also analyzed because in analysis we should get how much pressure or force is going to apply for these brushes or these things, how much force this bicycle here and here can bear, means force in the terms of load. Load of these things, attachments, and load of these attachments should be beared by the cycle. Then the user, normal user, can handle the pedal and it should be user friendly. So for that purpose, we have to analyze all the things in very specified manner and different analyses are available. So you can check on the net with the with putting some name that is bicycle, pedal bicycle cleaning setup. You can get different ideas for that. Now next one, see, this is the static structural analysis. So this is the Baha model, that is SAE Baha model, and which I have downloaded it from you. So here the 1D structure we have made. So this is the rod we have considered. This is also the rod we have considered, but we have applied the cross-sectional area which is uniform in nature. We have applied the cross-sectional area which is uniform. But here, here we can see the portion is actually red portion is having maximum stress or maximum deformation. So we have to think about deformation also. See here, in static structural analysis, the total deformation analysis is shown. Here 0 as a minimum and 9.9 0.97 into 10 raised to minus 5 is also the positive value. So that positive value, but it is very, very minimum information which is near about 0. So we can consider this as a fine model. Old model is very good and that we can consider for manufacturing. So for that purpose, we need to specify the control, that is 0 to 1.107, that is blue control. So I will tell you here for some, then so this blue color you can observe here, 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 not here, here, here. That blue color you can observe, that blue color is having deformation 1.107 into 10 raised to minus 5. Then next one, the sand color. Here we can observe, here we can observe the nearby color of that exactly blue color. Then it is moving towards green shades. The green shades we can observe here, green and yellow shades. Then orange shades, which will be nearer to red shades. Orange shades, which will be nearer to red shades. This orange shade means The deformation lies between 7.754 into 10 to minus 5 to 8.8622 into 10 to minus 5. Then above 8.86 to 9.97, which is maximum, that is lies here. So that is satisfactory analysis we are going to observe in this semester. Then there is another concept here, that is x-axis, y-axis, and z-axis. So this x, y, z axis we have to consider. There is a local and global coordinate system which we have to learn during the theory sessions, and you will have lot of knowledge of theory, and after that you can apply the theory into practical. So we are going to see it stepwise, but just now for concept events you can see this figure as that is contour is there, and you can observe the stress. uh, See, this lecture is this webinar is taken because what APA can do, that I have to tell to you. I wanted to tell to you. So after that we can start actual syllabus. Okay. Now next one. This is the car. This is the actual car, and as I have told in the previous slide, yes, previous slide, there is only and only structural analysis of this slide. Means what? The fixed constraints are given and force is applied. Then we are looking what is the actual behavior of that. But when we are going for any kind of thermal analysis, then we have to go for the atmospheric condition, weather condition. See, human body temperature is 37 degrees Celsius as we consider. So that 37 degrees Celsius from lies from the you can observe it in red portion shown here. You can observe here. This portion is having maximum temperature, but we know that some temperature is there that should be followed by body, and our hands are having some less temperature than that of actual body, and then after that other parts of the body are having very less temperature. But see here, the actual inner part is not shown. Where the temperature will be higher than our human body. So that part is not shown. It is only cut section of the car where the user is sitting, and this car model is made for only that purpose, whether the person can sustain the car temperature or not. So accordingly, the thermal conditions were given as an input, and output will come as a temperature distribution. So this is the temperature distribution diagram. In the next figure, this figure, you can observe this figure. So it is having x and y now. So if x and y is counted as 0, then horizontally if you are going for backward, then it will be x minus 1 y. Then this will be this will be what? That is x. Here, here x and y, but accordingly here x and y will be there, but x will be in the same direction. So it will be y minus 1. Now, if the question is about this part, then here x plus 1 and y, and here x plus 1, sorry, here x and y plus 1, and here x plus 1 and y plus 1. Likewise, we can go for pixel measuring in APA. So that is the concept of pixel in APA. And here. Now we will move towards next slide. That is, this is also tempo drawing. We can go for it. See here, fillet structure is there. You can observe here. This fillet structure is there. This is also called as fillet. So such a kind of fillet will have the element size. You can observe here this element size is different and this element size is different and quite shape is also different. So this element size and this element size is not same. So that creates uh, that creates some kind of error in the machine. So if we can we can mesh in a such way that is we can divide the given structure in a such a way that this element size and this element size quite similar. Means we have to divide this structure again into small elements and we have to mesh it again and again and we have to done fine mesh. That is the element size should be very small and which will be closer to this one and this one. So at the end we will get good quality mesh and we will get more accurate results than this model have. So this is the model which I supposed to say. Then next slide, we'll go for it. Now this is the scissor, hydraulic scissor structure. Actually, this was the model supposed to be manufactured by me. This was my dream project actually, and with the electricity I was making. But this was my first trial and error. That is, if we can move it up to fifth floor by telescopic arrangement, but that is not possible because it requires a lot of space. But still, it is analyzed by using the FEA software. So this model is having the blue things everywhere. Blue things means the model is more than safe according to our material application and according to our body condition application. On next slide, we are going to move towards. Now we are going towards our real life approaches, some daily life approaches that is we have. Now we are having in our room fan. So this is the blade of a fan. So here we can observe in both the figures we can observe here the blade face. Here the blade face means when the concept comes to join, the failure will happen. So we have to take care that our joint should be strong and the material used for joining should be good quality and we should go for some better modifications also. That is, if there will be fans which will be not having any kind of joint, that is whole structure is assembled structure, then that will be the best quality fan. The blades will not move here and there, and blades will be completely stick to the original model, main part of the assembly. So we can model it, but that is not feasible and that we are not facing because there are some other conditions are there. So we are facing the fan having some blades. So this is the another structure. This is not actually fan, but I have for concept reasons I have used this image. I didn't get the image, which is under analysis. Then there is another analysis which we can do, that is analysis of room. That is if fan is one in the room and that room is having area of 1 kilometer by 1 kilometer, then is it possible to for every person sitting in that 1 kilometer by 1 kilometer room to get air get that air from fan? No. So we have to analyze that how many fans are needed in that 1 kilometer room, and we have to analyze in a simple way. That is the flow analysis of air. This is the flow analysis done of air. This is the air condition. This is the flow of air in this room it is showing. So according to the flow, we can go for the number of fans arrangement in the same way. So likewise, we can analyze for our daily life channels. If you want, you can go for it now also by searching on it. That is analysis of airflow in a room. You will get the very good YouTube videos. So next one, this is another analysis. This is the structure, but I will consider it as a bed. So if the bed is there or table is there and which is around us right now. So on that bed, if person is sitting, then there the bed will fail or where the table will fail, where the structure will fail. The maximum failure count is count shown is in the red region, and the bed will not fail in the blue region. Now next one, these are nothing but our teeth. So these teeth are analyzed with the help of FTA, and there are some local views, occlusal view, and medial view, and we can observe here some teeth. So if anybody wanted to do analysis for any human body, and they can go for they want to go for good quality project by considering the medical field or any medical field, then they can go for such a kind of analysis also. Yes, FEA can be applied to this field also. So these basic things I'm not knowing in detail, but here the 100 Newton force you can observe here. I will mark it. 100 Newton force is applied to the root of the tooth, and here some sponge bone, periodontal ligament, sycomia post, ceramic crown, and gutta. So maybe medical people or some doctors are knowing this. So I'm not going in detail for this, but we can analyze anything in APA which we want to, and which is related to thermal or structural. Uh, uh, Next one, this is fine. So we can analyze the heart structure also, but for what purpose we need to analyze? The purpose should be clear. So for modeling or analyzing anything, our purpose should be very clear. Then next one, this is the steering mechanism. You can observe here the steering mechanism. As steering moves, the wheels are also moving. So this mechanism we can animate in Creo also, but if you want to analyze something, we must have to go for APU. This is another car model. So this is the structure analysis of car, which we are watching now. So this is the another kind of analysis. Here the model. Why I'm saying repeatedly where the model fails, because you may not, some people may not understand where the model is actually failing. So they are looking for only figures, but as per standard sign convention, red is the part which is considered as a failure, and blue is the part which is considered as a very safe. So, thank you so much. But before that, I want you to know about the basic things of ACL, which we are going to cover in the next lecture, and elements, the elements which are applied in the APA that we are going to study in this. So don't miss the next lecture and stay tuned for the YouTube channel. Thank you.